Hello, this is Mr. Craig, and the purpose for this video is because I plan on having a sub on January 23rd because I'm not feeling very well. Obviously, I'd be in class today if I were feeling well, but I came in last night and made this video, and I want to go over the highlights of the two worksheets before you take the quiz. And this video is only for periods 2 and 5 for January 23rd. Hopefully you guys got a good night's sleep with the thunderstorms that are planning on coming through at about 2 or 3 o'clock in the morning, but oh well. All right, let's go ahead and get started here. I'm looking at day 29, parentheses number 2, and the first part, and again, the way this worksheet and actually the other worksheet that I'm going to go over is the same exact format in which the quiz is going to be over. So what I don't want you to do is freaking out, wondering what's going to be on the quiz. Well, things like this. All right, so looking at A, where we have the IR2 parentheses SO3 outside the parentheses 3, it's pretty clear to figure out that the oxidation number for oxygen is -2. I won't give you anything other than -2 for the oxygen until a little bit later on when we talk about peroxide. So we're left with two things that we're not sure what the charge is, because again, iridium can have a multitude of charges and the sulfur can have a multitude of charges. So what we need to do probably to find out what the iridium is, and I would do that before trying to find the sulfur, is to let the nonmetal tell you what the charge on the metal is. Okay, so we know that SO3 has a -2 charge. Since it has a -2 charge and there's 3 of those, then we have to make sure that this balances out to 0 because there's no charge on this. We're over here. So if we have a total of a -6 on this side of the equation for the nonmetals, then the charge for all of the metals must be a +6. And since we have 2 of those, it has to be a +3. So once we have the +3 and the -2, then we can do our total charges to make it equal 0. And so since we have a -18 and a +6, the value that we're looking for that's missing here is +12. Since we have 3 sulfurs, take 12 divided by 3, that's your oxidation number. Again, these numbers are your oxidation numbers, not these. Okay? I think I've said that numerous times. All right, looking at B, there's a couple ways that you could have solved for this. Anytime that you have a group 1A or 2A or even a 3A element, metal, the charges won't change. They're either +1 for group 1A, +2 for group 2A, or +3 for group 3A. Calcium so happens to be in the group 2A. So you want to have your periodic table out when you're doing this sort of thing, because again, a lot of times or a lot of questions that were generated by most of you were wondering, well, how are we going to know what the charges on the calcium are? And my first response was, where's it at on the periodic table? So look on the periodic table to help you determine the charge. Now if it's a transition metal, then you need to do something like this, okay? So this is not one of our 10 polyatomics. This is actually bicarbonate. It's the same stuff that you find in seashells or actually baking soda. But when we look at that, again, remember if hydrogen's listed first, it's a +1 charge. If it's listed last, it's a -1 charge, unless it's in hydroxide. So if you want to do a sidebar equation, I know you probably can't see that very well, but the hydrogen has a +1. There's 3 oxygens in this, HCO3, so the total charge is -6 +1. Since we have a total charge of -1, then that means the carbon has to be a +4. So again, make sure that you can do that. Looking at C, again, aluminum, group 3A metal, always has a +3 charge. Oxygen always has a -2 charge. Find out how many of each you have based on your equation. Get the charges, work backward to help find what the charge on the 10 is. Okay, so again, these are the oxidation numbers. Rubidium, not a common element that we're working with quite a bit, but do look on the periodic table, group 1A, so +1. Oxygen -2, multiply it out so you can find out what the charge on the selenium is. Hopefully this will be relatively easy for you on the quiz. Looking at number 2, again, we're not concerned about the agents, since College Board came and said that we don't need to worry about those. So I'm going to listen. And if I'm asking you who's oxidized and who's reduced, especially on the quiz, it is being oxidized and it's being reduced. So don't write not redox. So don't leave anything blank. Probably the best thing to do on these is write the charges above. If you need to write the half reactions, write the half reaction. But you don't need to balance it out, okay? None of these equations should be balanced. If they are, it's on accident. So the osmium here goes from a +2, and that one's a +2, so that osmium hasn't changed. However, we do have one that goes from a +2 to a +6, and it only takes one to change for you to have an oxidation or reduction. Bromine goes from 0 to -1. That's taking on negative charges, therefore that's a reduction. Okay? So in this case, the osmium +2 is oxidized, where the bromine with no charge is reduced. When I'm looking for answers, and the AP exam will do the same thing, you want to tell me what element, not compound, not molecule, what element is being oxidized or reduced. The agents are the whole package, okay? So if I were asking about an agent, I would include everybody that's in that molecule or compound, but we're not worrying about agents, okay? All right, part B, we got chromium that has a +3 charge, going to chromium with a +6, becoming more positive. That means it's losing electrons. If you need to show the half reaction, you may. You're gonna have plenty of time to do this quiz. So losing electrons is oxidized. That's what the thing at the top of the review sheet says. Leo says GER. Oxygen, -2, -2, -2, -2. Doesn't change. Okay. It can change, especially if it goes to O2. So you want to look at the charges. Don't automatically rule out the oxygen. Also, if one thing's being oxidized, the other must be reduced. All right. Hydrogen, we have a +1 and no hydrogens on the other side. So that means if we're going to balance this, then that means there has to be some hydrogen ions somewhere else. Don't worry about it. If you don't see it, don't focus on it. However, the nitrogen goes from a +5, after you do the stuff that's up here, if you need to do that, goes from a +5 to a +4. So, when we ask about who's oxidized and who's reduced, something's becoming more negative, even though it's not negative, becomes more negative or gaining electrons, we say that's reduced. And again, the things we want to focus on are on the reactant side. We don't ever want to answer something that's on the product side. And I promise on the AP exam, they'll give you those options. All right, looking at C, the hydrogen goes from a +1 to no charge. That's becoming more negative. Therefore, the hydrogen +1 is reduced. Looking at the phosphorus, +5, +5. As a heads up, if you see a polyatomic on both sides and it's the same polyatomic, you can ignore it. Unless we have like PO4 and then a PO4 and then maybe a P2O5, something different, then you got to focus on it. But if you see the same polyatomic on both sides, and that's the only time that we see that, don't waste your time trying to find out what the oxidation numbers are. The mercury goes from no charge to a +1. That's becoming more positive, or it's losing electrons. Where's that half reaction? I may not have it on here. Looks like I don't. But it's losing an electron, becoming more positive. And then D, we have carbon with no charge, carbon with a +4. It lost electrons, it's being oxidized. There's that half reaction. Don't have to do it. Hydrogen again, no hydrogen on the other side, ignore it. Nitrogen, nitrogen, nitrogen. Anytime oxygen, my bad, oxygen, oxygen, oxygen. Anytime you see oxygen with something, it's going to be -2, unless it's with itself. So again, ignore the hydrogens. Oxygens, wow. Nitrogen, +5 going to a +4, that's becoming more negative. Therefore, the nitrogen +5 is being reduced. Sorry, got a little bit of a cold/sinus infection. You know it must be bad if I went out for a 7-mile run and got 2 in before I had to stop. So I wasn't feeling too well, guys. Wish I could be here. All right, I'm going to come on this side. All right, take a look at these. Hopefully there's not really any major issues. I'll just let you check these over. Don't forget the coefficients. Still double or whatever the coefficient is. That's a multiplier for your total charges. And always make sure that the charges are the same on both sides. They don't have to be 0. They need to be the same. Since we have 1 electron here, we have to multiply everybody by 2, which means that after you do everything on the reactant side, don't forget about the 2 for these guys, or else you're not going to balance out, and it's going to cause you to go crazy. Looking at B, we have bismuth going to bismuth +3. just one thing, so excuse me, just 3 electrons. And then we have our sulfate going to SO2. So again, the hierarchy here is balance your non-oxygen, your non-hydrogens first, then balance your oxygens with water molecules. So put your waters in to balance out the number of oxygens. After you do that, balance your hydrogens. So you may have some hydrogens on the other side. If you do, that's great. If you don't, even better. So we've got 4 hydrogens over here. So we need 4 hydrogen ions, not H2. Don't throw H2 in there. And then balance charges. So we have a +4, -2. So we have no charge on this side. So we need both sides to be 0 for this half reaction. We have a multiplier of 3 and 2. And then there's our equation. If this problem can be reduced, say that 3, 6, 2, all those other things can go into each other, simplify it, reduce it, smallest whole number ratio. And again, make sure charge is balanced, make sure you have the same number of atoms on both sides. Letter C, take a look at that. And these, and again, these are all acidic reactions. How are you going to know if it's acidic or basic? You're going to read the instructions. Okay. For the basic, number 11A, okay, had a lot of people trying to get real creative here, changing vanadium into hydrogen. Again, balance the non-oxygen, non-hydrogens first. So my first half reaction here, I just have this, and I'm going to balance out the hydrogens and the charges. In my second half reaction, all I have left is the H2. If I need to balance hydrogen, I balance it with hydrogen ions. Don't throw water in, don't throw vanadium in there, just remember the hierarchy of the balancing here. Be careful, because we need 30 electrons on both sides to make the charges the same. Don't forget about this -3, it's hidden there somewhat. That really should say +1 there, I don't know why it's a negative. And then, obviously, once we get, let me scoot it over, hopefully we can see that. Once we get to our hydrogen, where's our hydrogen? Let's see. 30, here we go, 3 hydrogens. And again, be careful. I would highly recommend that you underline your coefficient, because if you didn't have an underline there, it might look like you have 30 H's. Okay? Just something to think about when you're balancing things out. So again, make sure that we add the same number of hydroxides on both sides so that we can cancel out the hydrogen, and then change these into water molecules and then reduce. Okay. All right, letter B. Let's see here. And again, this line is here. These are the 2 half reactions. Take a look at those. I don't think there was anything really special there, except again, just like up here where we had the H2, we had the O2. So in the second half reaction, you just start with the O2, balance the oxygens with water molecules. Okay. And again, when you get to your final step with your total number of hydrogens, add that many hydroxides to both sides. Doesn't look as, oh, here it is. So I added 4 OHs to the 4 hydrogens, making 4 water. I already had 2 waters over here, so we simplify. So those waters go away, we're left with just 2. And then we should have same charges on both sides. So -8 and 4 times -2. Oh, my head is thumping. The last one, all right, so looking at this equation, part C, remember that we're going to use the P4 for each of these. So we get to use the P4 twice. Unlike up here, where we had the oxygen and the hydrogen, just remember that if it's not something that we can, to help get us more of the same things or to focus on, don't get creative. In other words, we wouldn't throw P4 in here to balance oxygen or to balance hydrogen. We would do it to balance phosphorus. All right. There we go. Take a look at those.